chart. Have you seen the exactly the electric field produced due to a charge? I know its value, but I have not seen it yet. Okay, that was all the part which you have not seen. Okay, but optics is something which you can basically see, right? And in this optics part only, in this optics segment, we will deal about ray optics and wave optics. Now, what is this ray and wave? Its value, but I have not seen it yet. Okay, that was all the part which you have not seen. Okay, but optics is something which you can basically see, right? And in this optics part only, in this optics segment, we will deal about ray optics and wave optics. Now, what is this ray and wave optics? So let me give you a brief idea before we begin with the actual topic of discussion. That when you see on a large scale level, okay, large scale level, that is ray optics. And when you go deep into the molecular structure, okay, molecular structure, or let's say molecular level, then in molecular level you will find wave optics. Okay, basically, let's say I am now standing over here. Okay, let us talk about you yourself. Then you are just watching the lecture, so you are a big body which is watching the lecture, the optical phenomena in a tab or in a mobile phone, which is bit more greater, right? Like if I just compare it with the molecular level, then it is too large, it is too vast, right? So here also you will feel that whenever you are dealing in the normal life level, we are dealing with ray optics. But yeah, when we go deep into the deepest level of it, we go and we study about the wave optics. Okay, that was the introduction to this topic. So yeah, let us now begin with this chapter. Okay, beginning with this chapter will first involve that I have to give you something about introduction. Okay, we will do something about introduction, about optics, about ray optics. Okay, once we are done with this, then we will come with the topic of reflection. Let me explain you how we are going to progress in this chapter. First, we are going to make our discussion about plane mirror, where then after plane mirror we will discuss about spherical mirror. Okay, once I'm done with the spherical mirror, then I will this is a segment of reflection. Okay, once reflection is done, I will move with the topic of refraction. Okay, where I will again discuss about lens, about let's say lenses, or about transparent body, just like a cube of just like a transparent medium, or medium with different refractive index. So yeah, our topic will be refractive index over here. Then we will discuss something about spherical lenses, and yeah, this spherical lenses will take a good amount of time over here. So yeah, this is something we'll discuss. Then we'll discuss the case of total internal reflection. There I will discuss about diffraction. Then I will discuss about dispersion. Once I'm done with dispersion, I will give you an idea about eye. And once I'm done with eye, then I will be teaching you about the various optical instruments. Optical instrument means the instrument which aid us to see. What does aid means? Aid means to support. Okay, let's say you might have seen many people wear spectacles. So why do they wear that spectacles? We'll get the reason of that. And you also might see that whenever I need to see a very small object, you might have seen people looking at the microscope. Whenever you want to see a very distant object, then you use the use of telescope. So what are that? And basically our entire discussion will be around this part only. Okay, I hope the introduction is clear to you. If yes, then guys, let us begin with the topic of ray optics. Okay, so at first let me give you the introduction of what is optics. So optics means the study of light. Now what is light? Okay, study of light is called optics. Got it. Now what is light? Light is everywhere around us. Fine, light is present everywhere around us. But what is light? Okay, light is that part of the electromagnetic spectrum which help us to see objects. Okay, that part of the electromagnetic spectrum which aid or which help us to see the object is known as electromagnetic, is known as light. Okay, let's say that are you able to see the screen? Are you able to see the lecture that or you are able to see the content that I have written over here? Definitely you can see. Why? Because light is coming from the screen that is going inside your eyes, and you can visualize it. Fine, got it. Is there any pencil around you? Okay, does that pencil also emit light from itself? No, pencil does not emit the light. Then how we are able to see it? Basically, in my room, there is a source of light, let's say a bulb or a fluorescent bulb, which is giving the light. That light is going on the pencil. From pencil, it is getting reflected. It is entering my eyes, and therefore I am able to see that pencil. Got it? So light helps us to see the object, and it is a part of the electromagnetic spectrum. This is a thing which I have already told you. Remember, okay? The last chapter was electromagnetic wave. Do you remember that? I have told that in that electromagnetic spectrum, there was a portion known as vibration. This was known as a visible spectrum, right? This visible spectrum is only known as light because they aid us to see the objects. Can you tell me at which range of the electromagnetic spectrum I can say that there is light? So that ranges from 400 nanometer to 700 nanometer. That is from violet till red. You will find that this optics can be divided into two segments. Okay, one is your geometrical optics and the second one is wave optics. Okay, where has ray optics gone? So ray optics is the other name for geometrical optics only. So yeah, we are having two branches of the optics, the ray optics and the wave optics. Okay, now what is the difference over here? So the study of light, in which light is considered as moving along a straight line. When we see that light is moving in, when we just assume that when we are studying the light, where light is something which is getting from the origin and it is moving, and it is moving in a straight line just like a ray. Okay, a line segment that is between 2 points, and one is ray which has one origin point, that is it is having a common point, but yeah, it can go up till infinity. Got it? So these were three things: line segment, and ray. So light is also a ray. Okay, it has a origin, but it can go up till infinity as well. Okay, fine. So whenever you see that light is traveling in form of a ray, that is under ray optics. When light meets a surface which separates two media, reflection and refraction can take place. So let's say that this is a ray of light. Okay, this ray of light just came over the surface. Okay, and once it came over the surface, what happened? Some of the light just gone backward, and some of the light just entered in this way. Okay, here you can find that some of the ray of light is just getting reflected, and some of the light has just refracted. So whenever you consider the ray optics, in ray optics you will find that the ray of light will just either get reflect or it will get refracted. Okay, the third point says that here the dimension of object very large compared to wavelength of light. This is a catch over here. Okay, like you will even see the formulas of wave optics, that this statement that I'm using right now is definitely the correct one. But yeah, for now you can understand that light is what? Light is a part of electromagnetic. Light is just an electromagnetic wave. I can say it is a part of electromagnetic spectrum. So yeah, light will be in the form of waves. So here you can say that between two troughs and between two troughs, you will find that there is a wavelength. This is the wavelength of light, which is known as lambda. Got it? Now I will say that this lambda, when the size of the object, let us say I am seeing this pencil, can you say that this wavelength will be greater than or will be smaller than that of the size of pencil? Definitely not. Okay, wavelength is in nanometer. Okay, whereas this pencil is about in centimeter, let's say it is about 5 centimeter. So nanometer is 10 to the power 9, centimeter is 10 to the power minus 2. You can clearly see the difference over here. Okay, so when the object size is too large as compared to the wavelength of the light, you will say that it is studied under ray optics. So the normal life optics that we observe in our daily life is what? The normal ray optics that we observe in our daily life is ray optics. Okay, what about the wave optics? So wave optics deals with the theories regarding the nature of light. So whenever I talk about the nature of light, like I was there to discuss that, yeah, the light that is emerging from here is a part of electromagnetic spectrum, which kind of wave it will form, what is the nature, what will be its path further onward, how will it frequency change, etc, etc, etc. So when I'm dealing with the nature of it, I call it under the study of wave optics. Provides an explanation for the different phenomena in light, such as refraction, reflection, interference, diffraction, and polarization. What does it mean? It means that with the wave optics, it has been experimentally proved that there are various phenomena of light, such as refraction, reflection, interference, diffraction, and polarization. All these phenomena exist due to light, and these all phenomena are just observed. When they are observed, they are observed under the ray optics. But how have we proved them? We have proved them by studying using them in the wave optics. Okay, so yeah, ray optics is something which we see, and wave optics gives me the explanation why I am seeing that. Okay, that dimensions of objects are comparable to wavelength of light. You will find that here, that is, you will find that, yeah, my wavelength was in nanometer, that was in 10 to the power minus 9 meter. Okay, you will find that
the problem is not effort, it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.